My name's David Northmore. I'm from a company called MarkLogic, and we were asked to come along and share some of the observations that we've had around the big data space in general. We've been going about 10 years. We've got about 500 customer implementations, and all of those are in or around big data. So I'll start off with a quick overview of big data and some of the trends that we've seen for a couple of minutes. Then I'm going to introduce Colin Wooldridge from O2, who's going to talk about some of the challenges that they've faced and how they've done so. And then I'll get straight into the meat of the overview of discussion. We've got a number of case studies that we'll talk through, about 4 in all. It's not a sales pitch, so I'm not specifically going to talk about MarkLogic, but I'll talk about how specific organisations have used technology to gain some kind of advantage. We'll have Q&A at the end, but if you want to stop me as we go along, I'll defer it if I think we're going to answer the question later. But other than that, just feel free to stop me and ask questions. With that, big data, I think I won't go through a specific definition, but big data basically relates to any information that is generated by people or machines inside or outside the organisation. And I think that's the fundamental difference. A lot of people draw parallels between some of the information explosions that are referenced in the 80s and early 90s. And the biggest difference from my point of view is that now people are concerned with not just with data that's generated inside the organisation, but more importantly outside. And recently there has been a massive explosion in that growth of data. I could read what Gartner say, but the key message, I think, is not about managing big data, it's about analysing it and leveraging it. And that's what we'll lead with in terms of the case studies that we talked about. The information landscape is going through a paradigm shift on a number of levels, and firstly that relates to, I talked about the explosion, the exponential growth of data within the organisation, the exponential growth of unstructured information. And those paradigms, the shifts that are taking place, I've heard referred in the market as the perfect storm. I'm not sure that's particularly appropriate, but when coincidental things happen and combine to create a massive shift in the weather, or in this case in the information landscape, that's often known as a perfect storm. Goldmacher at Cowan came up with a number of observations in terms of database technology in particular, but the data, the information landscape and the growth of data as a whole. And that's the biggest shift is the exponential growth. The other paradigm shift that we're observing relates more to a general loss of faith in the marketplace with what are sometimes termed by the analysts as mega vendors. That's a fairly significant impact, I think, in terms of the market as a whole. And again, people draw parallels to the 80s and 90s. If you go back that far, if you were around then, as I was, the major vendors in those days were DEC, Digital, ICL, to some extent IBM. But there was a failure there with that particular information explosion of those mega vendors to react and change, and that saw the growth of relational database technology. And I won't mention the names specifically, but there are a number of mega vendors now that are at the point of trying to address the changes in unstructured data, and that's created a lot of opportunity in what's called the big data landscape. One of the other paradigm shifts across the market in general relates to a general trend within the market for analysts to talk about, rather than talking about a vendor fitting all of your needs, they've started talking much more about applications needing to be fit for purpose, which again is a bit of a shift. Some would say it's a shift backwards because that's the way that people used to look at it before. But those are the 3 shifts that are causing all the fuss around the big data landscape. So before I get into some of the case studies that we wanted to talk about, I'm going to introduce Colin Wooldridge from O2 to talk about how this has impacted him and his team.
Thanks, David. So I'm Colin Wooldridge. I head up the IT strategy team at O2, or Telefonica UK, more correctly, but O2 is the brand name. We're a big telecommunication operator in the UK, but we're owned by a global telecoms company, Telefonica. And that does have a bearing on what we do on big data. Our big data journey has been going for about a year and a half now. And just to share, I suppose, some observations on that, the context to this is that mobile, for the first 10 years of this century, was a fantastic growth business, but it's less of a growth business now. And we have much more of a drive around efficiency and making sure that we do things once, both in a particular country, but also globally. And it's also, I guess it means that to us, big data is both a blessing and a curse. Okay, it's a blessing because there are lots of opportunities that you can put this capability called big data towards. And I'll give you some examples of some of those in a moment, but they cross all sorts of areas. They cross the marketing team, financial services team, the operations area, etc. And so there's lots of opportunities, and that's fantastic. But it also means there are lots of stakeholders, and whenever you have lots of stakeholders, that makes it quite hard to take something forward, because you have to give something to all of them, get them all lined up and behind it. It also means that there are lots of people out there selling point solutions to us. So, for example, I think Matin talked about some of the things this morning, like analysing all of the calls that are made into your customer service team for sentiment analysis. That can be sold as a point solution. But part of my role in IT strategy is to try and make sure that we do build capabilities that can be applied to all sorts of those opportunities I talked about. And that's quite a hard sell, because now what I'm trying to do is say, we'll build this big data technology capability once. Then you've got to think about the analytical side of things as well. So we've been hearing about how hard it is to find data scientists. The question is, does every area that wants to apply some of that analysis find its own data scientists, or do you try and find a single team and build that team up so that it serves all the areas of the business? Because what we're trying to do is do those things once. And I guess just to give you a couple of examples of the opportunities. So one opportunity that we've talked about for years in the mobile network space is we have thousands of cell sites. Each cell site has hundreds of parameters associated with it, and changing those parameters impacts the performance of the network. And through the course of the day, some of those cell sites get really busy, and the performance on those starts to degrade. So we want to be able to identify the characteristics that result in lowering the performance of the network in real time, so that we can try and do something about it. We might do some traffic management, or we might actually enter into a conversation with a customer where we'd say, well, we've spotted that in your area you're using data, but the 3G data network is not performing well in that area, but we can also see that there's a Wi-Fi capability in the area that you're in, and as part of your contract with us, you get free access to that Wi-Fi network. So we might start moving into the realms where we'd communicate with a customer and say, in order to improve your experience, why don't you switch over to the Wi-Fi network? And you might say, well, you could just do that by communicating with customers and telling them that generically, if they have any trouble, why don't they try the Wi-Fi network near them? Well, guess what? We used to try that, but it doesn't seem to work very well, because what you really have to do is seize the moment and do it in real time. If someone's having trouble, tell them, because that's when it's relevant to them. So that's one area. So that's the network team that we might go and talk to, but it's also the CRM team, because the marketing CRM team are going to be interested if we're talking to a customer about how we're going to impact the customer experience. And that's what I mean about multiple stakeholders. It's not a case of just one part of the business coming up with a big data solution and developing it on a point basis. All of a sudden you've got lots of parts of the company involved. And what happened in Telefonica is, having got some progress in the UK, we then had the conversation about, well, hang on a minute, shouldn't this be a global capability? And interestingly, the organisational aspect of that gets really quite heavy, because all of a sudden you have to say, well, does that mean we need to build a central team who are going to be responsible for the big data technology? And are they going to be responsible for the data analysis as well? Because maybe that's a way of attracting data scientists, but also if they're a scarce resource, let's just have one area recruiting them rather than lots. And that really does become quite a big challenge, which I haven't heard people talk about so much today, but actually organisationally, how do you make this a reality in an efficient way? That's a really big challenge. And I guess the other thing that's linked to that is everybody wants it. Everybody's got 500 different ideas for how they can apply big data, all those things that get left on the cutting room floor that we can now do something about. The challenge is, what's the value of any one of those opportunities? Because the minute you ask someone, well, that sounds great if we tell people to switch over to Wi-Fi, we'll build that capability for you. How many people do we think will actually switch over? What will it do to our retention rates? What will it do to our customer satisfaction? Will it actually allow us to cross-sell or upsell to any of those customers? It's funny how you get that tumbleweed moment and no one seems to want to come up with an actual number. So I guess the two things that I'd take from this on, absolutely, the technology is a huge challenge and it does seem to be maturing a bit. Getting hold of data analysts, yeah, absolutely, we've been through that ourselves, thinking through what we can do about that. But the ones that have really cropped up for us on top of those are this one about organisationally, how do you address this opportunity in an efficient way? And the other one is, how do you choose which of these opportunities to go after first, so that you can actually prove you're making some progress and take your board and the various other parts of the business that are stakeholders in this with you on the journey. And I guess that's where we've got to so far in O2.
Great, thank you, Colin. That's actually a great segue into what I was going to talk about, which was the fact that big data means pretty much something different to just about everybody that you talk to. Certainly different organisations face very different challenges and opportunities in talking about what's largely lumped into the big data framework. So hopefully we'll see that with regard to the case studies that we're going to talk through. I'll jump straight into that first point with these example use cases before starting to talk about technology in a very general, broad sense to try and categorise some of the opportunities. But as I say, these 4 case studies, I'll pick 4. 3 are commercial or private organisations and 1 is focused on government, but in each case they're trying to achieve something slightly different by getting a handle on this mass of ever-growing unstructured data within the organisation. The first one I'm going to pick is actually BP. BP faced a challenge within big data around trying to improve their intelligence in a specific area that I'll go into in a minute in order to gain a competitive advantage. I think everybody, particularly the Americans, know who BP is, but people tend to associate them with oil exploration or a retail petrol site. They're actually a huge commodity trader, particularly in oil and gas. So in Canary Wharf, you can go see a trading floor that is just like a bank's. If you're familiar with it, you'll know what I mean. If not, it really is just like a bank trading floor. Now, a commodity like oil and gas is, particularly in transit, is subject to a whole bunch of different factors in terms of its value in the marketplace. It's affected by political considerations, particularly political unrest. Weather obviously plays a massive part in shipping oil, in particular, around the globe. Where oil is at a particular point in time has a marked bearing on its particular value. A vessel, in terms of trading oil, its payload, its draft, as well as its location, its current capacity, all of these things combine to make lots and lots of different variables around the price at which oil can be traded. Before we got involved with BP, I didn't appreciate that oil in a particular vessel is traded all the time. On average, in crossing the Atlantic, the contents of an oil container is traded 4 times. And the kind of things that they get concerned about is, well, if there's a weather issue somewhere, in a part of the world, maybe they need to divert a particular tanker to put it somewhere else, to unload its oil, its cargo, and move somewhere else. But all of this information is dealt with real time to try to seek an advantage, basically to trade on that commodity market and make more money than you otherwise would. Real time, I guess, is the key there in terms of trying to define a differentiation between BP's oil trading capability and its competitors. It's about getting that information accurately and faster than the competition, so that if it's appropriate, you'll sell a particular cargo or buy another one. The kind of queries that you might want to run, I mentioned their location. Geospatial data is pretty important in an application such as theirs. And the kind of query that they would be concerned about isolating would be to know how many barrels of crude are in transit currently in the Gulf of Arabia, for example. And their system in real time is able to tell them that, so that they can take a view as to whether their trade price for a particular cargo is up or down. And they'll make real-time decisions based on that. Weather, we talked about, there are a stack of other variables that are fed into a system real time and put into one interface on a trading desk. So that, if you like, it gives the ability for end users to set specific triggers and alerts and make real-time decisions that impact their business very significantly. It's a very, very profitable part of that industry, and in particular for BP. So that's one application of big data, unstructured data and information that's applied to gain a very significant advantage. And in terms of the competition, that's viewed as a real jewel currently for BP. We heard just now from Colin something about sentiment analysis, and there's a lot of buzz in the marketplace about sentiment. The next one that I'm going to talk about is actually an organisation called Nielsen. And a lot of people will know them because they're one of the preeminent TV ratings organisations. But they actually provide information on a whole host of different product lines, particularly in terms of their application in the marketplace. So they'll advise people that are concerned about advertising, for example, around TV schedules or washing powder, a whole bunch of different products. What people know them for predominantly is the TV rating, and from their point of view, that's quite a crowded market now. It's quite a tough, difficult market to innovate within, or to gain a new advantage, to add new or different products, new values. And that's what this particular project was about. So they designed a system around capturing a whole load of sentiment analysis from a range of those opportunities, I should call them, on the left-hand side. So it's things like Facebook, it's blogs, it's tweets, it's Twitter. And they're trying to capture information to add value to their general information products, so that they can not just talk about specific who's and whens, as it's titled here, but they're also advising advertisers on the how and why of why a particular campaign or product is successful in one particular area versus another, or a TV program is more successful at one particular time in one particular region over another. And that now is seen as a fundamental plank in these guys generating significant new revenues and getting into new markets. So again, that's another very different use with a very different objective for trying to capture big data within the organisation. I'm going to talk quickly about a government-based opportunity. It's actually a US government-based, and it's known as an open source intelligence application. And this one is slightly different. It's not about profit or market share or time to market. It's actually about dealing with and reacting to threats, specific threats. I mentioned earlier one of the key differentiators from our perspective with big data is that largely it's not just about information inside the organisation, it's about information outside, i.e. it's about stuff that generally you have little ability to control. And that's really what this particular system is about, this particular application. It scours a range of open source, i.e. publicly available websites. You can see there Google, Flickr, YouTube, a whole bunch of sites across the globe, and it's looking for particular patterns or particular items. They're in all kinds of formats. They're images, they're videos, web pages, text, all of the above. And the ability to capture that information, again in real time, to identify specific threats is a very significant application. So I think in order to understand that a bit better, it's worth looking at a specific objective. And in this case, it's dealing with smuggling. So these are real source files that were found on Flickr, and there are tweets associated with smuggling that indicate, or can indicate if you can spot them, that there's an increase in smuggling in a particular part of the world. So having identified an objective to try and eradicate that, to do something about it, you need to mark up relevant associations, and the OSINT application does just that. So in this case, it's looking at that Flickr page, and it's drawing associations between a URL, an image, a text that's related to that, as well as emails that relate to it, and maybe timestamps. Now, in defining those associations, what that application does is go and look for that pattern, and it alerts or identifies variances from it. So that's about trying to spot strange patterns or strange elements of behaviour that are then triggered to individuals that go and investigate. And again, that's a very different application of technology to meet a big data requirement. But that's one that, again, is very successful. That's a publicly accessed one. The last one that I'm going to talk about relates specifically to getting the right information from lots of different sources into the right place, and it relates to an organisation called Elsevier. Elsevier is a publisher, both online and paper. In the UK, they're predominantly a scientific publisher. In the UK, for example, they publish The Lancet, which is the journal of the British Medical Association. They're part of one of the biggest publishing organisations in the world, and they also provide specific information to medical staff across the globe. And this is a big data application whereby they've taken a whole bunch of content and detail within their set, and they make that available to radiologists in this case, who are diagnosing specific issues. It's about getting lots of complex information to the right place at the right time. If you know anything about that area, typically, if you go back not too many years, it was about having 6, 7, 8 big manuals and books open at one time and trying to look at an X-ray in this case and diagnose a problem, identify what it was. Well, this is about providing that information online immediately to make faster diagnoses, and you know, that's another particular use of technology around big data. So I hope those were interesting. That was 4 case studies that we pulled out that maybe highlighted different aspects about trying to gain an advantage. They're different in every case, and they're all trying to meet significant objectives for each of those organisations. The second area on the discussion topic that the Big Data Insight Group pushed over was related to the technologies that are required to satisfy these kind of big data requirements. I doubt that there's too much that's new to people on this page, but there's no doubting that database technology isn't going away. People talk about the difficulty in applying traditional technologies to managing unstructured data, but the database issue, you know, we're not going to see the end of databases. Rather, we're seeing a whole host of databases crop up into the marketplace. They all do slightly different things in slightly different ways, but that's certainly a trend within the technology sector over the last 3-4 years. Because there's so much text involved in any unstructured data requirement, search technologies, again, have taken a real boost in the last 3 or 4 years. And that, again, is going to be fundamental to applications moving forward. That's all bound up in the same requirement, effectively. Around hardware, I think there's a growing trend or a requirement to use ubiquitous hardware and to ensure that we're making the most of it. So it's difficult now to talk about requirements that involve specialist hardware. Wherever possible, certainly we're in the market, we're finding that people are much keener to use commodity hardware and to get every last ounce out of it. That includes the storage end of it. I was at a seminar not so long ago where somebody suggested that nowadays to design or build a new database, a new piece of technology to address the big data market, you'd either have to be mad or extremely confident that you could develop a product that was going to add a significant value over and above what's available in the market now. But what's changed over the last 30 years, if you look at the last key wave of, or information explosion as it's sometimes referred to back in the 80s, it's a completely different problem now. If you look at the requirement, we've talked about volume. I wasn't here this morning to hear the keynotes, but you probably saw something that referenced volume and velocity and complexity and so on. So the assumptions, the requirements around database technology are completely different now to those 30 years ago. So it's no surprise that we've struggled recently to manage this explosion of unstructured content or data. And just because there's more data coming at us, it doesn't mean that there's any tolerance for a lower performance. Again, we've found, if anything, people are getting more concerned about performance. It's often the case also that the textual content, there's something specific about text that is very relevant to a specific user. And again, that's a big change in terms of the technology over the last few years. So in looking at technology, in determining what it is that we've got to address, the design decisions around technology now are vastly different to when relational technology came around. I won't read through all of those because they're probably going to make sense to you as you look at them. But things are very different now, and that's why we've got this issue around managing unstructured content. It's not just about the information. We've seen examples that include all kinds of formats and all kinds of types of data. This kind of information, it highlights the information explosion, the exponential growth. You're all familiar with that, I know. But equally, I talked then about commodity hardware. The rapid advances that have come about constantly mean you get more out of less. And again, we're faced with the need to get much more out of commodity hardware and to sweat that much more effectively. That's a big requirement now. The little box on the right-hand side talks about real-time everything. And again, that need to be performant to equip an end user, whatever his or her function is, with up-to-date real-time information such that they can make a decision now that impacts the business is critical. Again, that performance requirement is, if anything, getting much more prominent in any particular requirement. And if you put all of that together, again, certainly in terms of any critical requirement, we're under pressure to ensure that we're integrating, for example, with a particular data management suite, whatever it is. We need to make sure that the solutions that we're putting in integrate with data center policies. And that to some extent, influences the debate over open source. There are lots of open source products doing lots of different things in the big data space, and sometimes that's an issue. If you're looking at a mission critical application, you probably want to talk about high availability. You've probably got quite strong, big demands around disaster recovery, for example. And those kind of enterprise fit-for-purpose issues and considerations are certainly requirements that are pushed at us and seem to be getting more and more important as we move through things. Let's come back to what we said about fitness for purpose. You can look at this a number of ways. If you look along the bottom, we've got normalized or structured data and unstructured, therefore denormalized data. Up on the left-hand side, we're looking at the requirement for interaction with data, which varies from fixed, fairly straightforward queries through maybe more complex ad hoc queries, but nevertheless batch queries. And at the top of that area, in terms of value, we're looking at real-time, more real-time applications, ad hoc queries. If you're looking at structured data, HDBMS is fundamental to all of this. A data warehouse traditionally addresses a batch requirement, a batch need. But around big data, the column on the right with an unstructured database management system, these are the ones that are picking up more and more in the market. If you look at the batch system, we do an awful lot of work in Hadoop environments now, and I don't know if that's something that you've talked about this morning, but around the MapReduce area or batch requirements, Hadoop plays a big part in most of the implementations that we look at or consider. And at the bottom, for fairly straightforward things, we've seen the rise of organizations like Google over the last several years, and that's about key value stores. So in terms of looking at fitness for purpose, we need to make sure that we're putting the technologies in the right areas, the right boundaries. You can actually, at the bottom, if you notice there, the normalized and denormalized change to enterprise scale and internet scale, and that again reflects the fact that we're now dealing with data outside typically the organization, and that's why the volumes have increased so much. I mentioned Hadoop there, and again, another observation, the kind of conversations I've certainly had over the last 12, 18 months, there's been an awful lot of confusion about who does what where and what technologies you should be applying. Most of the technologies that I've talked about aren't mutually exclusive. So as I say, we're working in lots of cases with large Hadoop implementations of one flavor or another, and we work a lot with Hortonworks and Cloudera in solving specific applications. So if there is a big requirement for real-time analysis, that generally represents quite a high value area within the data set, but typically there's a need to offer more of a batch process around potentially Hadoop, for example, and the ability to offer a seamless solution that distinguishes between those two, but makes it available to the organization is increasingly important. The next discussion topic that we were asked to look at relates to asking the right questions. And typically in a more traditional environment, we've been used to defining exactly what it is that we're expecting to get out of a specific system. We've done a lot of work within the relational world around defining schemas before we implement and deploy. And when the requirements change later, we spend a lot of time reanalyzing that, recutting it, and re-implementing a system. But I think it's increasingly with unstructured information. Generally, people don't know at the outset what it is that they don't know. And again, I won't read through every line on here, but typically it's the case that a big data application now needs to offer the end user some kind of advice and guidance on how to navigate the data set that you're trying to make decisions with, or that is impacting your business in some way. I'll talk through an example here. This is a publicly available website called MarkMail, and it's an application that you can go check out, go look at, that is for the developer, IT developer community. It's been running for a couple of years now, 4 years. It's got something like 64 million documents. And if you go check the website out, you'll see that that's incrementing, you know, every few seconds, every few minutes. So that's a good example of a data set that is growing exponentially. It's not meant to be an example of an application that is generating, you know, a massive growth in someone's top line or that's cutting costs out of the bottom. But it does show how important it is to refine or be able to search with unstructured data in the knowledge that you don't necessarily know what it is that you're going to be looking for tomorrow. So for example, in this is just screenshot, it's not a demo, but were I looking for within that population, and you can try this later if you want to, if I was looking for the use of the word semantic in that data set that happens to comprise 64 million documents that developers from all over the world have logged on this website. I could type semantic into the top, and this would return a whole bunch of different values. This is a faceted search, so it's trying to help me narrow down on what it is that I'm interested in terms of the use of semantic. And if you look at this later, you probably can't read those numbers. I can't read those numbers particularly well here. But there are lots and lots and lots of examples of areas within that website, within that data set that use the word semantic. So I need to try and narrow that down somehow. And if you look at one of them, it talks about the types of formats. So I may know that it was an attachment, and maybe it was in PDF. So if I type that in, it will give me a refined data set here. If I know it was a PowerPoint presentation, I can refine it even more. And if, as I browse that content set, I know that it's about ontology, or it was concerned with ontology, and you can see a preview effectively of one of the emails that's registered on that website. If I hit that particular example, it will return me the slide set with the word, the term hit. So I've just found a specific presentation that uses that word amongst that enormous data set. I don't know if that was useful in terms of demonstrating what faceted navigation needs to mean to people now, but the ability to help the end user get to data that's relevant and purposeful fast is a massive requirement. And it's also a massive problem with traditional technologies. It's not easy anyway, but that's something that most of our customers are spending a lot of time working with us. And that's a particularly interesting development, I think. This was slightly more difficult. The discussion area here, we didn't spend quite so much time on it. I know there have been presentations on the kind of things that Colin talked about around the organisational impact, the soft or human side of trying to implement a data application. But in terms of the technology, I think it all comes back to the purpose or the objective of an application or an end user. And the technology, from our point of view, is purely a facilitator. We're trying to make sure that we're knocking over or meeting business requirements, not technology requirements, that we're providing information and access to real-time data that makes a positive impact on the business in whatever guise that means. It's also important, I think, along the way, as requirements change, typically we see the need for end users to start defining what I call triggers and alerts earlier. That increasingly is something that we're told to view as mandatory as opposed to an IT exercise. In conclusion, if we sum up how the organisations, the companies, the customers that we have been looking at the big data challenge and how they've succeeded, what's of concern to them, there are always lots of ways to look at anything. Here's a fairly cliche example of a glass that's half full of water. Is it an opportunity or is it a problem? And there's another visual that indicates there are lots of things that you can look at with big data applications. A lot of the science projects that kicked off around Hadoop, for example, were analysing data and looking backwards, which may be very valid. But increasingly, we're finding that people are more concerned to look forwards with big data apps and try to make decisions about, maybe based on historical information, but around incrementing future revenue streams or cost lines or whatever. And if you look at the kind of data that people are beginning to impact or address now, it varies widely in terms of value, but increasingly people are looking at the left-hand side of that, and the guys that we've found to be most successful are generally focusing on the higher value opportunities, where they're probably looking forwards typically and are trying to increment a bottom line, or are trying to make decisions that strategically impact their business moving forward. And that's pretty much what we had to say in terms of the observations around that discussion set. So I'll throw the floor open to anybody that wants to ask or probe or has got any questions. I think we've got about 5 minutes, either of me or of Colin.
The VP example that you opened up with is a very interesting example. The 6 data types that you looked at, 5 of them were really easy to understand what that data is, location, GPS, and put it, pinpoint on a map. But the first one you started was politics. How do you pick up such fuzzy data? The Crown Prince's salary review changed yesterday. How does that impact BP trading? How do they get that into the system and work out?
That's typically they're analysing data from, for example, a news feed. Could be sentiment analysis. It's not in their case, but I'm sure it will be moving forwards. That's a bit like Nielsen. But actually, the geospatial data that you talked about isn't just about a GPS line. Typically that data is much more complex than that. The system that we're talking about at BP, regardless of BP, there's every 5 minutes globally, I can't remember the name of the organisation that publishes this data, but there is a data feed that broadcasts information on every single vessel that is on the sea everywhere in the world. So they take that feed every five minutes. They analyse that subset, and from that big pool of every single vessel that's out there registered on the sea, they take the subset that relates to oil containers. And it's trying to marry that kind of data, which actually that's not trivial, but it's trying to marry that kind of data around the geospatial feed that goes with it to determine where all of those things are in the world and where they're headed. So, for example, they'll try to spot patterns of specific ships heading for the same depot, the same terminal, because any terminal can take so many ships and the rest of them have to wait outside. And that's a big issue, a big deal for trying to offload oil, for example. So the political one is kind of difficult to quote in terms of an example, but political turmoil, that kind of information needs to be fed to a trader really quickly. But the rest of them probably aren't as trivial as maybe you'd think, because it is about analysing payloads. It's about looking at information that maybe you didn't have earlier, but you've just been given on a specific ship that is empty or full, and acting accordingly. Any more questions? Okay. Thank you for your time.